Now, ladies and gentlemen, up really soon, we are elated and excited to introduce 6 Singapore energy startups who will share their perspectives and roles in accelerating the energy transition. And this will be presented by Shell. But before we invite our panelists up on stage, we'd like to first invite up on stage Ms. Nicole Powell, Social Investment Advisor, Shell Singapore. Ms. Powell, all yours. Let's give her a round of applause, shall we? Invite her.
A very good morning, distinguished guests, ladies and gentlemen. This morning, I'm really excited to share with you that we will be having 6 local startups present their innovations to you. They will talk about how they are supporting sustainable development for Singapore and the world. We are proud that these startups are part of our Shell Startup Engine Singapore program this year. Shell Startup Engine is our global innovation program that develops energy startups. While the global transition to a net zero future is picking up speed, with countries and companies around the world, including Shell, setting net zero emissions goals, we believe this momentum can only be sustained if everyone collaborates to support society's journey towards a lower carbon future. In particular, the inventive and entrepreneurial energy of startups are increasingly looked upon to play a part within the low carbon value chains. Shell Startup Engine is in line with our own targets of becoming a net zero emissions energy company by 2050 or sooner, in step with society. The program also aims to create lasting value for society through enterprise development. For the Singapore edition, we take in early to mid-stage local energy startups, put them through an accelerated 6-month program. This includes building up their capacity through workshops, knowledge sharing sessions, mentorship by our own Shell colleagues, and external advisors, providing them with showcase opportunities such as this one today. We hope to help position them for success in the smart and clean energy landscape. And we are also very glad to have Energy Market Authority EMA as our official program partner for a 2nd consecutive year, providing the startups with post-program funding opportunities that help them progress to the next stage. Without further ado, I hope you enjoy the conversation and session. Thank you.
Thank you, Nicole. Now, with that introduction, just builds in the excitement to hear from our startups. Allow me now to introduce who they are. We have Shin Ng, CEO and co-founder, Rush Owl. Goh Eng Wei, CTO and co-founder, BX. Dr. Peter Finn, CEO and co-founder, Synectify. Could I invite our panelists to make their way up on stage, if you will? Now, ladies and gentlemen, moderating this session is Program Director of Shell Startup Engine Singapore Startup Bootcamp, and this is Beth Henderson. Let's invite them all up on stage as they make their way up. Oh, we're just getting their mics in order, ladies and gentlemen. Again, as we wait for our panelists to make their way up, do ensure, for those of you who haven't already downloaded the SU app, you should do so, because we see all the agendas right there and the bios of our speakers there as well. Now, importantly, as we move forth, could we invite our panelists up on stage, please? Importantly, as we move forth, feedback along the way would be very essential for us to see your thoughts as well through the entire program of SU. Okay. Everyone's in good order. Beth, the floor is yours. Enjoy the session.
Great. Thank you very much. Hi, everyone. I'm Beth, the Program Director from Startup Bootcamp, and we are a global network of industry-focused startup accelerators and the delivery partner for Shell Startup Engine. So we will be hearing from our 6 startups in 2 groups of 3. They'll be doing their 90-second elevator pitch for you, and then we will be opening up to audience questions. So please do submit those, and I look forward to hearing those. So I'm looking forward to welcoming our first startup to pitch. Please welcome Shin Ng, CEO and co-founder of Rush Owl.
Hi, everybody. Nice to meet you today. It's my pleasure to be here. So just a little bit of fun fact. Do you know that when we conduct a global survey, 60% of young working adults today actually want to reduce their carbon emission. But when you ask them, how are you going to do that? Most of them are going to say they are going to take a public transportation instead of buying a car. But here's the thing. Not everyone has access to good and reliable public transportation. For some of them, it is not even an option. Today, public transportation is still a privilege for cities who can shell out billions of dollars on infrastructure. My name is Shin, and my company Rush Hour Singapore is trying to create the next generation mass transit network where we can leapfrog lengthy government planning and hefty budgets spent on infrastructure. And using our AI-driven platform, we can consolidate this demand and create a mass transit network all online. Today, with our platform, we are able to commute to our everyday destinations. We can pull communities using our AI-driven platform. And in this case, instead of taking a cab, instead of riding a car, what you can do is to really pull into a high-capacity vehicle that can send you into your everyday destination. And when you look into these deployment at scales in developing cities, the result is phenomenal. You're actually saving up to 30 car rides and the carbon emission off the roads every single day. Just imagine the impact that it can do for very congested, very polluted cities. And in Rush Hour, what we want to do is to leverage on this community that we have built to really create a carbon zero, digitized public transportation network. We believe it is the best way to create accessibility and leverage on this movement to include and bring in electric vehicles, to not only just reduce carbon emission, but to make it carbon zero in the end. So thank you, everyone. Let's work hand in hand to create the most sustainable public transportation that we have today. Thank you so much.
Thank you, Shin. Our next startup I would like to introduce now, Engwei Go, CTO and co-founder of BX.
Good morning, everyone. My name is Engwei, CTO of BX. Okay, underwater work is mandatory for the safety of critical marine infrastructure such as oil and gas jackets, ports, and wind farms. Today, the work is being done by human divers, which is extremely dangerous. And when it's being done by marine robots, it usually requires a large support vessel, which is expensive and highly pollutive to the environment. Today, CO2 emissions from ships have doubled that of international aviation. An offshore support vessel emits about 15,000 tons of CO2 per year. You couple that with $50,000 a day rate and a 100-man crew that needs to be sent out offshore to be exposed to risk, we have a very huge problem on our hands. We believe that maritime autonomy is the key enabler to reduce and remove this need for large vessels and specialized personnel to be sent offshore. BX designs and manufactures hover-capable autonomous underwater vehicles that can be operated by anyone, launched from any vessel, and also unmanned surface vessels. Leveraging on our 9 years of research and development into autonomous marine vehicles, we believe we have the right ingredients for this. The current value that we bring to our service providers and asset owners is 3 to 5x faster and more comprehensive data that's actually really collected on their infrastructure. And this enables our asset owners to make timely predictions about the asset integrity of their structures. When we started with an offshore autonomy trial with an oil and gas operator in the Gulf of Thailand, and that has led us to develop our first vehicle, which has been used to gain traction around the whole of Singapore. And we have recently closed our seed round of investment to grow the team and also develop more vehicles to enter and capture the offshore wind market. Our team comprises of a strong team of both business and engineering, and with strong affiliations to academia, which ensures that we stay on the bleeding edge of marine autonomy development. Finally, we would like to partner with like-minded individuals to trailblaze a new era of underwater inspections, so as we build towards a safer, more cost-effective, and sustainable future. Thank you.
Thank you, Eng Wei. And for our third startup, I'd like to introduce Dr. Peter Finn, CEO and co-founder of Synectify.
Yep, good morning, everyone. I am Peter. We are Synectify, and I'm here to introduce our lead product, Chrysalis. And the reason we're building Chrysalis is because right now, in the amount of time that it's going to take for me to work through this presentation, our energy grids globally are going to waste about 1 megawatt hour of electricity. Intermittent renewable generation is actually one of the culprits. Not only is an energy source that strains our grids, but also, of course, during peak periods, it produces overgeneration that the grid cannot absorb. The energy sources that are off-grid are also one of the problems, like our flare gas, which is stranded power and cannot be brought to market. So with the planet heating up, and all of this waste energy available, wouldn't it be great if we could more efficiently capture some of it? What if, for example, we could take our energy demand closer to where the energy supply is, to basically just cut the grid out of the equation? That is what we are doing with Chrysalis. We have designed a modular, containerized, high-density computing solution that we are able to deploy directly at the sources of surplus generation to convert that surplus into revenue-generating, high-performance computing services. We basically provide a flexible load to match an intermittent energy supply. And in the process, we are producing a new type of market that hasn't existed before, and that is a global spot market for computing power that is based on energy cost and availability, and enabling a circular economy for renewable energy transformation. We are looking for business partners, energy producers, and investors to partner with us to fulfill our vision of offsetting the past and renewing the future. That is Chrysalis. We are Synectify. Thank you.
Thank you, Peter. And great work, those three pitches. They're used to pitching through Zoom, and it's nice to be on stage again. So we'll now open up to audience questions. So please, anyone in the room or online, open up the SUE app and join the live discussion. I will start our questions, though, with a first one I've prepared. So can each of you please elaborate more on some of the emerging challenges you see in your respective areas as the energy transition advances and how your solution tackles them? I'll start with you, Shin.
All right. So I think that for us, we have been trying to push electric vehicle commercialization for the longest time. Well, I believe that right now in the market, we still see there's a slight premium in terms of electric vehicle pricing. And that actually sort of make vehicle fleet owners think twice. So in this case, what we are really trying to do is to amass the kind of ecosystem that we have here. People who are really in our transport ecosystem that really believes in going green and willing to pay for that. And we believe that with this growing amount of people in our network, we can actually one day really talk more to the fleet owners to really adopt more vehicles like that. That's what I've been trying to do. Yeah.
Great. And same question for you, Eng Wei. For BX, how are you tackling those emerging challenges?
Okay, I think so. This green energy transition and green renewable energy, one of the biggest challenges that is stopping the transition is really about cost. We're trying to ensure that these such renewable energy solutions can be as cost effective as a fossil fuel based kind of solution. And when we usually energy operators talk about OPEX and CAPEX costs, and ensuring that the OPEX costs can be still something that makes financial sense is definitely something that will be the biggest driver to whether this change is going to happen. And for us, we are coming from the other angle where we believe that we can help renewable energy companies actually drive this the cost of OPEX down, and really because of our solutioning And for us, it's also an additional benefit because the types of renewable energy structures actually benefit autonomy a lot more, given the larger scale of deployments that's needed to be able to generate that much energy, especially in the areas of offshore wind farms and also floating solar PV farms. So that's where we see us being able to accelerate this whole transition.
Yeah, absolutely. And for you, Peter, what is Synectify doing?
Thanks, Beth. So, I mean, one of the challenges is we are essentially a grid flexibility solution, and there are a lot of other solutions out there. There's also a significant amount of heterogeneity among energy grids, and so one of the challenges that we see for ourselves is kind of fitting ourselves into this really dynamic environment. But our product has really a significant niche and a role to play. It's a relatively new type of grid flexibility and ancillary service, and so there also is some education to do. And so these are some of the challenges we're confronting.
Yeah, thanks. All right, question. I'll go back to you, Shin, for Rochelle. So looking out to the wider region around Singapore, how significant is the opportunity for mass transport electrification in other Southeast Asian countries, and what are some of your expansion plans?
Well, definitely in Singapore, it is a very interesting market. Right? I think that we are all looking forward to the electrification of vehicles that we take every single day. But I would like to really divert the attention more to sort of the Southeast Asia kind of scale, right? Where we look into places like India, where we look into places like Malaysia, where public transportation is not really existent, right? And I think that we're using this kind of, leveraging on this kind of trends, right, all over the world, right? What we can really do is to massively sort of like accelerate the electrical adoption by leapfrog this transport plan that we have. And really create an ecosystem of that. Yeah. So I think that's what we've been trying to do for the longest time. And I think that by joining this program, we hope to find really like-minded partners to help us expand really into these places that require these infrastructures.
Yeah, absolutely. That's what this event's all about. We do have a question actually from the audience for you, Peter, from Tim. Can you describe a bit more about the solution? What are some of the inputs, outputs, a bit more about the tech in the box?
Right, yeah. Thanks for the question. So the solution is basically the pilot that we're running. We have one running in New York right now. Is basically a modular containerized data center. It is an ISO form factor Tricon, which is basically 1/3 of a 20-foot. And that is basically GPU servers, and it's running on an air-cooled cooling circuit. There's no water curtain. We're testing a couple of different modes of connection. We have a fiber connection, but we also are installing Starlink. So that we can start experimenting with wireless data transmission, which we think will be important in some of the stranded power applications.
Yep, thanks, Peter. Question for Eng Wei. So we know that your co-founder, Grace, is actually over in Europe at the moment looking for some opportunities and what the opportunity is over there. Can you tell us a bit about how does the opportunity differ between geographies, and where do you see your biggest market?
So geography between Singapore and Germany, in Europe, right? Mm-hmm. Okay. So I think one thing for sure is the market is a lot bigger in Europe as compared to Singapore. That's one. But one of the biggest things we have to derive for ourselves is really we are up there to look for the biggest value that right now that we believe we will be able to bring about, which is to the wind farm operators. Here in Singapore, we've managed to gain quite a bit of traction, really because the nearshore market is actually quite significant, and there's quite a number of deployment opportunities, and the technology itself, there's a huge market gap in the nearshore region, and we've managed to capture quite a bit of those opportunities here, but our foray into Europe, it's really about pushing right into this huge opportunity in wind farms. That's where we're going towards. And we've also actually explored into Taiwan as well. So in fact, worldwide, everywhere, everybody's building. US and not just Taiwan. You have the US, you got South Korea, you got Japan. But the market that is the most open to external companies really going in is really Europe. And at the same time, they're also actually at the most forefront of wind farm deployments, which quite a number of these contracts are actually achieving the completion of where they are transiting the O&M stage. So that's where we're pushing greatly into that. The other value that we are testing out is really about the value of a manpower cost. So in Singapore and in Asia, the cost of manpower is still lower versus that in Europe because of our developing nation status and just really the different geographies, right? So in Europe, they place a lot more premium on this manpower, and because today's methods are very manpower intensive, they're very reliant on a very skilled pilot, and very well-equipped vessels. So that's where we see us being able to push this technology to be able to be able to gain a much greater traction when we actually go into them. We validate the assumptions here in Singapore. We've managed to get it to a stage whereby it is adopted by people over here in Singapore. And with that, we believe that we can do and scale even further when we actually move over to Europe. Simply from a cost standpoint, from a manpower standpoint, these huge values that the asset owner sees in our kind of solutions. Yeah.
Yeah, thanks. And I guess building on that theme of emerging problems as the energy transition continues, to you, Peter, do you think with more and more countries exploring and advancing their use of renewables, will it ever be possible to have a grid with no volatility or stranded power?
Thanks, Beth. That's an interesting question. It's kind of a theoretical question. It's like asking, are we ever going to reach a point where we have perfectly efficient markets? And so I guess leaving the theoretical part of it aside, I think that we're definitely going to see an increase in efficiencies, and not just with solutions like we're trying to bring to the market. Basically, grid flexibility is going to be enhanced across the board. It's going to be enhanced on the supply side, on the storage side, as well as the demand side, which is where we are. But I also think that with all of this talk about smart grids, one of the smartest components in our energy ecosystem are actually human beings. And that is not just in terms of the talents that we bring to bear in the innovation space, but also in terms of our ability to adjust our own habits of energy usage. And so I think we also have a role to play in increasing the efficiency of our energy markets on the demand side. And I think we're going to see more of that.
Good, thanks, good answer. That was a tricky question. Now we are about halfway through, so I will now invite our three startups to swap over. We'll hear from group 2, so thank you so much, Peter, Xin, and Eng Wei. Okay, so we're going to do a bit of a change over here. So while we fix up the chairs, I'm just going to tell you a little bit more about some of the things we're doing in the program. But I'd also really encourage everyone watching today, we really would love you to connect with the startups after the session today. So if you heard something you're interested in, you want to connect, find out a bit more, maybe you can help them, maybe you can make a helpful introduction for any of them. That's really what today is all about, is collaboration and hearing about new ideas. So connect with us on the Shell platform. We can help make those introductions. I believe we are ready now to bring our next group of 3 startups on stage. So our second group is around the theme of new fuels and waste reduction. So we'll be hearing their pitches shortly, and then following the same format with Q&A. So please do go into the app, send us your questions. Really want to guide the discussion by what you want to hear about. So I would now like to introduce our first startup from Group 2, Tilika Raj, CEO and co-founder of SunGreen H2.
Thanks, Beth. Distinguished guests, ladies and gentlemen, it's a pleasure to be here today. I would like to introduce SunGreen H2, where we are building advanced materials for the green transition. And we're accelerating net zero by unlocking green hydrogen potential. Hydrogen is a $150 billion market, almost entirely produced from fossil fuels today. Made in this way, it's adding 10 times as much carbon dioxide as hydrogen. Water electrolysis is a means of producing hydrogen by running renewable electricity and water through an electrolyzer machine to create a zero-carbon renewable fuel. A global landslide of legislation is driving this. However, if we want green hydrogen to compete with gray, the cost has to become competitive, and the target is $2 per kg. The current bottleneck to affordable green hydrogen is electrolyzer technology. It's expensive and inefficient at the moment, and for high performance, the industry relies on platinum group metals, which are also limited in supply. SunGreen H2 is solving this problem by harnessing the power of nanotechnology to build electrolyzers to dramatically improve hydrogen production. We double hydrogen production by using 10% lower energy consumption and reduce the amount of platinum group metals used by 30 times. This is how we are unlocking green hydrogen potential and setting us on a path to realize less than $2 per kg green hydrogen today. The technology is under patent. We have strong inbound interest from all over the world to commercialize. The team is bringing 10 years of research expertise and commercial experience to commercialize the technology. We are looking for business partners, industry partners, to take our technology from the prototype that's running in A*STAR's Institute of Materials Research and Engineering today to bring it into proof of concept pilots for demonstration and production of $2 per kg of green hydrogen. Join us. Thank you.
Thank you, Talika. Next up, I'd like to introduce CJ Kang, Marketing Lead for GreenCop.
GreenCop turns your trash into cash. So when you're sipping on your favorite cup of coconut shake or your sugarcane juice, what happens to what's left behind? Billions of tons of agricultural bio-waste are generated because we don't consume the entire thing. And this is, what we do with them is that we burn them, we throw them away, causing serious land and water pollution. The GreenCop's patented technology converts your bio-waste into valuable bioresources, such as biofuels, sugar, and lignin, so giving these agricultural producers another stream of revenue. What is unique about GreenCop's solution is that it is green, there's no secondary waste, it is faster and cheaper to convert the bio-waste, and it's easier to deploy. So current methods such as the steam explosion, they are energy intensive. They require high pressure and high temperature to convert these bio-waste. We have gotten our first funding from NUS GRIP, and we have applied for 3 patents, and we are in talks with customers on how to scale up from 10 kg to converting hundreds of tons of bio-waste a day. Our team of dedicated experts, as well as our academia advisors, helps our customers more effectively convert their bio-waste, as we give an end-to-end solution, a customized, tailored solution to your needs. And finally, if you want to get more out of your bio-waste, you want to drive sustainability, come talk to us today. So I'm CJ from GreenCop. Thank you.
Thank you, CJ. Excellent pitch. And lastly, I'd like to invite Dr. Massimo Spina, co-founder of Reacto.
Thank you. Hello, everyone. Did you know that it's possible to burn water? Each year, Industries produce more than 70 billion tons of highly toxic and non-biodegradable industrial wastewater containing persistent organic pollutants. Common practice is to store this waste on site, then truck it off-site for incineration, and these incinerated ashes are then sent to the landfill. While this process releases a considerable amount of greenhouse gases, almost 1% of the global water withdrawal is wasted through a high energy intensity process, and this percentage will double by 2030 if we do nothing. At Reacto, we have combined 18 years of expertise in material science and wastewater treatment to create a breakthrough process that uses graphene to double the energy efficiency to completely decompose the toughest organic pollutants. Our patented technology not only enables companies to safely treat their waste on-site and residual-free, but it recycles hard-to-treat wastewater and minimizes the waste sent to landfill, while saving costs to up to 50%. Starting from Singapore, Reacto aims to become the sustainable solution for hard-to-treat wastewater that are currently incinerated, so that we can save enough fresh water for millions of people in water-scarce countries while reducing greenhouse gases emissions and minimize the energy consumption. We are looking for partners and collaborators to join our mission. Speak with you soon.
Excellent pitches from the three of you. I'd now like to invite audience, please submit your questions. We'll take some questions from the audience, but I'll start off with our first question to the three of you. Can you elaborate more on what differentiates your solution from existing ones and how it's supporting sustainable development? So starting with you, Talika.
Thanks, Beth. Great question. I think one of the main bottlenecks why green hydrogen is not entrenched as far as grey hydrogen is entrenched in the industry is cost. So as mentioned, the electrolyzer technology to date has been inefficient and expensive. And in order to produce more hydrogen, in order to improve efficiency, the industry has been relying on platinum group metals. Now, this is simply not a sustainable solution. If we consider a transition and a green hydrogen demand of somewhere around 100 gigawatts, out of which about 80 gigawatts is already legislated in Europe, for example, and it's coming to Asia Pacific. Increasingly, we see adoption in this part of the world. Then we simply don't have enough critical mineral resources like platinum and iridium to make electrolyzers scale up. One of the key innovation needs in this technology is to reduce the amount of platinum and iridium that goes into these electrolyzers. So that's one way in which we solve this bottleneck. We have a nanotechnology-based process in which we use low-cost, earth-abundant materials, perform our magic, and nanostructure them. We perform nanocrystal engineering. And what we're able to do is literally improve dramatically the amount of surface area of the materials available for the water-splitting reaction, which is basically extracting hydrogen from H2O. In this manner, we're able to double hydrogen production at the very least. And it's quite simply related to the cost of green hydrogen. Hydrogen cost is capex and opex divided by the lifetime production of the hydrogen. If you're doubling the number in that denominator, we're immediately halving the cost. For space-constrained nations like Singapore, where we have a bit of a resource crunch in terms of land, this has an important implication. When you're able to produce double the amount of hydrogen from a given electrolyzer stack size, you immediately reduce the footprint by half. So now we're talking about a solution that can provide a low-cost option in space-constrained areas. We're developing the tech to be very modular, like a Lego building block, so that there is no large, huge capex barrier either for adoption. If you want a kg per day of green hydrogen, you can simply use one of our modular blocks. And if you need 100, let's work with you to build a plant that uses 100. So that's how we're trying to address the challenges that the industry has faced so far.
Thanks, Talika. And you actually have some of your equipment at the expo here today if anyone wants to go and see it in person. Absolutely.
We're at ACES next door, and we would love to invite everybody to come and have a look at our prototype electrolyzer up and running at ACES. SunGreen H2 is there.
Great. And I'll turn to CJ. Can you tell us a bit more about some of those barriers for the uptake in the industry and what you're doing about it?
So the challenges is with biofuels, there's a bit of controversy because when do we use land for food and when do we use land for fuel? So for GreenCorp solution, we are converting the bio waste into valuable resources. So we're not fighting, we're not competing to get land for food because we already know, there's this world hunger issue right now. Yeah, so this is one of the challenges, and we overcome it by converting the bio waste. And secondly, would be current methods. They are usually high energy intensive. They require anaerobic. You need it to be in a vacuum environment, high pressure. You need to have the reactors at 200 degrees Celsius. Whereas our solution, you can do it at room temperature, at current pressure. And so this helps us to save about 80 to 90% of the energy cost, and making this solution very sustainable and green. Yeah.
Yes, great. And same for you, Massimo. How's Reactor doing differently?
So some of the wastewater treatment process are 100 years old. And up to now, there was no technology that could effectively treat these highly toxic, persistent organic pollutants at high concentration in wastewater streams from industries. But now is an imperative urgent to try to maximize the energy efficiency in every process we have, because we need to reach net zero by 2050. And that's why, for the last 6 years, we combine our expertise in material science engineering and wastewater treatment to create this process that can efficiently decompose these pollutants completely and on-site, enable companies to not only reduce their costs, but also reuse this water, because water is a precious element, like energy. And 1% of the global energy demand is used for wastewater treatment. And wastewater treatment releases 5% of the greenhouse gases emissions. So it's something that cannot be ignored, and that's why we're building our technology and trying to bring it to the market.
Yes, excellent. I'll go back to you, Talika. A bit of a theme we've heard at SEU this week is about Singapore's plans to import energy, and also really hydrogen could be a really big game changer in that space. So what do you see as your role in supporting the trading of hydrogen?
Thanks, Beth. Great question. Singapore has already committed to importing up to a third of green electrons. And one really interesting pathway or option that becomes available at this stage is, what do we do with the green electrons? We've got an import coming in, and with all imported energy and produced energy, grid stabilization is the thing that matters the most. One of the key enablers of a technology like green hydrogen from electrolysis is to harness very efficiently your green electrons. So use them when you really need them. But if you've got excess, for example, these can be stored seasonally in large volumes to provide an element of energy security via renewable energy storage. This works not only at grid stage, it also works in a decentralized manner. So let's talk about our diesel gensets that are powering up and the diesel trucks that are plying our highways. You have an option for amending that via a green hydrogen and fuel cell-based storage system from small scale to large scale. This has applications in our data centers and the way we grow our energy consumption going forward. So in these ways, once we have the green electrons imported, of course, there's a number of ways in which we can expand the way we use those green electrons within the Singapore ecosystem. The other option is, when we talk about technologies like SunGreen H2s, where we're reducing the cost of green hydrogen, we're present in Australia, we're working in the US and Europe as well. We believe that by lowering this cost, we help to bring the entire ecosystem forward. So from the point of production till the point of storage, transportation, your final delivered cost of hydrogen is actually what is getting impacted. Today's hydrogen produced in large-scale centralized production facilities, by the time it's delivered to the customer, this is the fossil fuel-based stuff, is almost doubling in delivered cost. By finding a modular way to produce green hydrogen on site, we're immediately cutting out your need to transport large quantities of hydrogen and start harnessing what you can on site today. This will, of course, be augmented by large-scale import, and we believe that we can work at both ends of the equation to provide a better solution at the end of the day for customers.
Thanks, Talika. And building on that similar theme with what you're doing, Massimo, with Reacto, I know one of your core value propositions is about treating that wastewater actually on-site and not having to transport it elsewhere. So can you elaborate a bit more about what does that on-site installation look like and how that is so impactful?
Yes, thanks. So it's no surprise that road transportation consumes a lot of energy and releases a lot of greenhouse gases emission. And to think that companies have to store the waste and track it off-site, and then they have to import other wastewater, it doesn't make sense in the view of a circular economy. So what we design is an on-site solution, a turnkey, that can just take the water and just by using electricity can decompose these pollutants and enable the water reuse in the industry itself, in the manufacturing plant itself. So we are really closing the loop and contributing to a decentralized water system. So we cannot have a centralized water system if you want to minimize greenhouse gas emission. We need to eliminate transportation. PUB is working toward that direction to have wastewater treatment plant next to treatments, but that cannot apply worldwide because in big countries that are not energy dense or country territory limited like Singapore, transportation is a huge component of the wastewater treatment energy demand. And that's why we're offering an on-site solution.
Yes, excellent. CJ, question for you. Can you tell us a little bit more about your go-to-market plan and your roadmap, and maybe how that's maybe changed a bit in the last year or so?
Yeah, thanks for the question. So we know Singapore, we don't have agricultural producers. When we first started this, we were talking to our customers in Malaysia and China, where there's the agricultural producers there. But because of the travel restrictions, we're unable to go to the source and to set up a pilot plant. So what we did next was to look back into locally, where else can we help Singapore market? And we are starting to have talks with NParks vendors, and they come to us saying that they have hundreds of tons of garden waste to be treated. So our plan has shifted a bit, and now we are working more locally. And when the travel restrictions are up, we can actually propagate our solution in the region.
Absolutely, very creative pivot. I'm sure many startups have had similar challenges with COVID and having to slightly adjust their plans to survive for the past 2 years. Another question for you, Talika. I know one of your biggest sort of claims is being that world's sort of highest performance electrolyzer. It's a very big claim. So can you tell us a bit more about how you verified this?
Yeah, thanks. Absolutely. So as mentioned, we have our prototype electrolyzer system up and running at A*STAR, Institute of Materials Research and Engineering. We are very grateful to be supported by A*STAR, and we have been collaborating with them for some time now. And we have turned to A*STAR in the first instance for validating our materials and making the measurements. And as explained a little bit earlier as well, what we measured is the amount of current density that we produce for the given amount of energy input. This is a critical indicator when it's a bit technical. It's a critical indicator when you measure the performance of an electrolyzer and the ability to produce hydrogen. What we found is, compared to the existing commercially available technology, our solution is able to produce about 1.3 amperes per centimeter square of current density. These are the materials that we are patenting. And this compares very nicely with what is commercially available at less than half an ampere per centimeter square. So when we say we are doubling hydrogen production, it's a little bit over double. And this is for one particular type of technology. We have a platform technology. We can produce materials for alkaline, PEM, and AEM electrolyzers. And we go step by step and validate the material performance and characterize the cell current density versus the voltage for each of them. So this is some of the work we're doing, and we would be happy to explain further about this. Please do visit us at ACES. We're in the booth next door.
Wow, super impressive stuff there. Now, probably time for one last question. I'll turn to you, Massimo. So what you've described, if you're able to scale that and deploy that globally, it could have a tremendous impact. So can you tell us a little bit more about, what is your roadmap look like, and how will you plan to be able to scale it up?
Yeah, thanks. So we plan, of course, to start to Singapore. Singapore is a perfect launchpad to pilot our technology with some of the end user here. We are aware that some of the companies we are talking with, they have a need for this technology. And after we validated our pilot and our operation running here, we are planning to scale up first in Southeast Asia, when there is a big manufacturing, but there is also the growest population with the lowest water resources. So water is the most precious. And after that, we're planning to expand in Europe and US that are more regulated countries, but they also have more available for water resources. So really, we want to make an impact in Asia when we see this contrast between population and water demand and demand for energy efficiency.
Yes, absolutely. Makes sense. Well, thank you to the three of you. I did want to finish the session by just telling everyone that we do have our Shell Startup Engine Demo Day happening on the 10th of February in 2022. So what you've seen here today is almost like a sneak preview into their pitches. They'll be doing a longer pitch at Demo Day, and also we'll have some more very insightful discussions about the energy transition then. So please do just reach out, drop us a message if you'd like to attend the hybrid event live streamed globally. So we would love to invite everyone to attend that next year too. So with that, I'll wrap up. Thank you so much. Thank you to our 6 startups, and really look forward to hopefully making some more connections after this session. Thank you.
Thank you, everybody. Thank you. And thank you, Beth, for managing this very lively discussion. All 6 startups, we wish you well. Let's give them a round of applause, ladies and gentlemen, for their presentation. Very nice.